Welcome, everyone, to this deep dive into the online encyclopedia of integer sequences. You probably know it as the OEIS.
A fundamental tool.
Absolutely. Essential for anyone studying number theory. It's this incredible catalog of sequences, right? Exploring their properties.
Precisely, a treasure trove.
Today, we're focusing in on one specific sequence. It's A000197. Known as the double factorial sequence.
Yes, A000197. It's got a very neat definition, actually. The formula is simply AN equals N.
The factorial of M.
Exactly that. Simple to state. Well, the results are something else.
Okay, let's get a feel for it. The first terms, you start with 1, then 1 again, then 2. Seems pretty tame. But then the fourth term, A3, that's 720. Quite a jump.
It is. And that's just the beginning of the story.
And then A4, the fifth term. Well, starts 620-4484. I mean, it's enormous. The beginning is 620-448-40173333943943936000.
And that number just keeps going. That really captures the core nature of this sequence. It's the exceptionally rapid growth.
You can say that again? From 720 to the...
That fifth term, A4, has 199 digits. So we're not just talking exponential growth here. Applying the factorial function twice like this leads to what you might call hyper-exponential growth.
Right, hyper-exponential. It's truly staggering, and it makes you wonder, what's the point? What can we learn from a sequence that just explodes like this?
That's a great question. It's precisely that explosive growth that's interesting.
Okay.
It tells us something fundamental about the factorial function itself and, the power of iteration in mathematics. The comments in the OEIS entry actually touch on this.
Oh.
Hofstadter apparently noted something interesting. He suggested that sequence is growing even faster than this one. Well, they often grow too fast to even warrant their own entry.
Really? So the sequence is kind of like a limit?
In a way, yes. It serves almost as a benchmark within the OEIS for, let's say, extremely fast growth.
Yeah.
It really puts A000197 into perspective, doesn't it?
It certainly does. A yardstick for extreme growth. Okay, so besides just being huge, the OEIS entry mentions other properties. Something about divisibility.
There's a connection to powers of 2.
Right. It says AN is divisible by 2 raised to the power of A245,087N, but not by the next power of 2.
Exactly. And that sequence, A245,087, it actually counts the number of trailing zeros in the binary expansion of AN.
Okay. So the divisibility by powers of 2 is directly linked to its binary representation.
Precisely. It's a fascinating interplay. You have this iterative factorial structure, these huge numbers, and then you look at their base 2 form, and the number of factors of 2 tells you about the trailing zeros. It shows how these different areas, sort of multiplicative properties and binary structure, are connected.
That's neat. Very elegant.
It is.
The OEIS also mentions something about prime divisors. For n greater than 1, the largest prime divisor of AN is the largest prime that's less than or equal to n itself. And that sequence, the largest prime XEOK, that's A006990.
That follows quite directly from the definition, actually. Since AN is n, you're multiplying all the integers up to n. So naturally, the largest prime factor involved in that massive product has to be the largest prime number you encounter up to n. It's a logical consequence.
Makes sense when you put it like that. Now, going back to the sheer size, I saw a note that the fifth term, the 199-digit one, is actually only available in the B file for the entry.
Yes, that's quite common for sequences with terms that grow very large very quickly.
It really just highlights the scale, doesn't it? The practical challenge of even writing these numbers down, let alone doing calculations.
Absolutely. The formula n is so simple, so compact, but the values it produces, they quickly become computationally challenging, exceeding standard limits.
The entry also gives another way to think about it, using function composition. It says AN, A000142, applied to A000142N.
Right, and A000142 is just the standard factorial sequence, n.
So it's literally factorial n.
Exactly. It's just a different notation emphasizing the iteration. You apply the factorial function, get a result, and apply the factorial function to that result. It makes the structure very clear.
Very clear. And then there's something about the sum of the reciprocals. For a sequence growing this fast, you wouldn't immediately think about summing 1 over each term.
You might not, but think about how quickly those terms grow.
Okay.
The reciprocals, 1AN, they become incredibly small, incredibly fast. 1 over 720 is already pretty small, but 1 over that 199-digit number is minuscule.
Right, vanishingly small.
So the sum actually converges very rapidly. The OEIS identifies this sum as another sequence, A336686. It's a common thing with sequences that grow super exponentially. Their reciprocal sums often converge.
That's quite counterintuitive, but makes sense. Fast growth means fast convergence for the reciprocals.
Precisely.
Now, for listeners who want to play around with this sequence, the OEIS entry is quite helpful. It includes code snippets.
Yes, for Maple and Mathematica, I believe.
Which is great. It lets people actually compute the first few terms themselves and get a direct feel for this explosive growth.
Definitely. Having code examples makes it much more tangible. It encourages exploration.
And finally, like most OEIS entries, this one has cross-references, links to related sequences.
Yes, the web of connections.
It lists A063979, A152168, A000142, the factorial itself, of course, A006990, largest prime less than or equal to n, and A245087, the exponent of 2 we talked about.
Those cross-references are invaluable. They're pathways, really, to understanding how this sequence relates to others and to broader mathematical ideas. Following those links can lead to some really interesting discoveries.
It shows how everything's interconnected in the OES world.
That's the beauty of it.
So, wrapping up our look at A000197, the double factorial sequence. It's more than just big numbers, isn't it? It's a statement about iteration, about the nature of growth itself.
Indeed. It pushes our intuition about scale.
It really makes you think about where else this kind of, hypergrowth might appear in mathematics, perhaps in more advanced areas of number theory or combinatorics. Where do we encounter, or maybe even need, things that grow this fast?
That's a profound question. Understanding these extreme rates of growth is crucial as mathematics continues to explore more complex systems. This sequence, in its own simple way, gives us a glimpse into that world of immense scale.
A fascinating glimpse indeed. Plenty to think about there.